Good morning, students. We are going to see the simulation of AM modulation and its spectrum using MATLAB. Okay. So the aim of this experiment is to write a MATLAB program for the generation of AM for the generation of AM and FM signal and plot its spectrum. Okay, so what is the aim? We have to generate a MATLAB program for the generation of AM and FM. So first what we are going to do is, first we are generating the AM, then second we are going to generate the FM. Okay, and we are generating the AM and its spectrum, then FM signal and its spectrum. The equipments which are needed to do this experiment is, we need a PC with the Windows operating system, and we need MATLAB. Okay, already you have studied in the basic simulation lab about MATLAB. MATLAB is nothing matrix laboratory. Okay, now the procedure for doing this experiment is, first you have to switch on the power, then you have to open the MATLAB software by clicking the MATLAB icon in the desktop. Okay, then you have to open the editor window and you have to write the program in it. After writing the program, you have to save. So you have to save by using M5. Then you have to run the program and you have to view the graph. This is a general procedure for all the programs. Okay. Now we are going for the explanation of the program. So we are going to generate AM signal. Okay, AM signal and its spectrum. Okay, and its spectrum. Okay, so amplitude modulation. What is amplitude modulation? Varying the characteristics or varying the amplitude of the carrier wave in accordance to the message signal or modulating signal. Okay, so what is AM modulation? Varying the amplitude of the carrier signal in accordance to the message signal or modulating signal is called amplitude modulation. So first what we are going to do is, we are going to define the frequency of the modulating signal. We are going to define the frequency of the modulating signal, amplitude of the modulating signal, frequency of the carrier signal, and amplitude of the carrier signal, and modulation index. So here we are taking the frequency of the modulating signal or message signal as 20. Okay, we are taking the frequency of the message signal as 20, and we are taking the frequency of the carrier signal as 500, and the amplitude of the message signal is 1 volt, and the amplitude of the carrier signal is 1 volt, and we are taking the modulation index as 0.8. We are taking the modulation index as 0.8. So what are the things first we are defining? We are defining the frequency of modulating signal, amplitude of modulating signal, frequency of carrier signal, and frequency of amplitude of carrier signal. And after that, finally we are defining the modulation index, that is 0.8. 0.8. Then what you are doing is, we are defining the x-axis and y-axis. We are going to draw the, what are the things we are going to plot is, first we are plotting the message signal. We are plotting the message signal. Then we are plotting the carrier signal. We are plotting the modulated signal, modulated AM signal. And finally we are drawing the spectrum. Okay, we are drawing the spectrum. So for this message signal, carrier signal, and modulated signal, the x-axis is time. For the message signal, carrier signal and modulated signal, the x-axis is time. For spectrum, the x-axis is frequency. For spectrum, what is the x-axis? X-axis is frequency. So we are defining the frequency and time. Okay, so time you are taking from 0 to 0.0999 with an increment of 0.00001. Okay, this is your time axis and this is your frequency axis. Okay, we have defined the time and x-axis. Okay, this is for first three and this is for your spectrum. Okay, now you know that for the modulated signal, you will be having an upper envelope and lower envelope. For the modulated signal, actually the modulated signal will be like this. This is your VC is 1 volt, no? So this is VC, this voltage will be VC. From VC, the envelope of your modulated signal is nothing but the modulating signal. Okay, it will be like this. Similarly, here also this is a envelope. Okay, these two are, this is upper envelope, and this is a lower envelope. Then after that, this is your modulated signal. Its amplitude is varying according to the message signal. Okay, this is actually this total, this is a modulated signal. So this is your upper envelope, this is your upper envelope, this is your upper envelope, and this is your lower envelope. Okay, this is your upper envelope and this is your lower envelope. So first we are going to define the upper envelope and lower envelope. So upper envelope is nothing but VC plus modulation index into sine 2 pi FM into T. Okay, so what is your upper envelope? Upper envelope is VC plus, actually this is a 0 line. Upper envelope is VC plus modulation index into sine 2 pi FM into T. Then you're going for the lower envelope. Please listen, this is in the negative side. The lower envelope is in the negative side. Okay, the lower envelope is in the negative side. So we are putting a minus. We are putting a minus. And we are taking the upper envelope as V1. We are taking the upper envelope as V1 and the lower envelope as V2. Okay, so the lower envelope V2 is equal to, since it is in the negative side, we are putting a minus. Then VC plus mu sine 2 pi FM into T. Okay, so this is your V2. Now we have defined the upper envelope and lower envelope of modulated signal. Okay, modulated signal. Now we are going to define the message signal. This is your message signal. This is your carrier signal. Okay, after defining the upper envelope and lower envelope of modulated signal, we are going to define the message signal and carrier signal. The message signal, we are taking it as Vm. Please listen, this is capital Vm. Okay, capital Vm is equal to small vm into sine 2 pi FM into T. This Vm is nothing but the amplitude of your message signal. FM is nothing but the frequency of the message signal. Okay, now capital VC, this is nothing but the carrier signal, is equal to small vc. Small vc is the amplitude of carrier signal. small vc into sine 2 pi fc into t. Okay, now we have defined the message signal and carrier signal. Now we are going to define the amplitude modulated signal. Okay, we are going to define the amplitude modulated signal. The amplitude modulated signal VAM is equal to VC, that is the amplitude of carrier wave, VC into 1 plus modulation index into sine 2 pi FM into T. Here then you are multiplying that with the carrier signal. Okay, so here you are going for element by element multiplication. Okay, here you are going for element by element multiplication. Please listen. VAM, that is nothing but amplitude modulated signal, is equal to VC. VC is nothing but the amplitude of carrier into 1 plus modulation index into sine 2 pi, that is you have to put star. Okay, sine into sine 2 into pi into f m into t into, okay, so now you have to close this bracket, 1 plus modulation index into sine 2 pi fm into t into this, here you have to go for element by element multiplication, dot into star into sine 2 into pi, here also you put pi, okay, pi fc into t. Now you have defined the amplitude modulated signal. We have defined the amplitude modulated signal. So I will once again explain this first part of this program. First, our aim is to find the amplitude modulation, or you simulate the amplitude modulation and its spectrum. So in order to do that, first for amplitude modulation you need two signals. One is carrier signal, another one is message signal. The amplitude of the carrier wave is varied according to the message signal. So first we are defining the frequency and amplitude of carrier signal and message signal. So we are taking the amplitude of, we are taking the frequency of message signal as 20, carrier signal as 500, the amplitude of message signal as 1, the amplitude of carrier signal as 1, then we are taking modulation index is equal to 0.8. Then we are defining the x-axis. Okay, for drawing the or plotting the message signal, carrier signal and modulated signal, we need time axis. Okay, so we are defining the time axis, and for plotting the spectrum we need frequency axis. So we are defining the frequency. After that we are defining the upper envelope and lower envelope of our modulated signal. After that we are defining the message signal and carrier signal. After that we are defining the modulated signal, AM modulated signal. Okay, now after that, in order to find the spectrum, you know that if you take the FFT of the signal, then you will be getting the frequency information of that signal. Okay, so what you are doing in this step means, in order to find the spectrum, first you are going to take the FFT. Okay, if you take the FFT, you will be getting the frequency information. Now you are defining VF. In VF, you are taking the absolute value of the FFT of VAM. What you are doing? In VF, you are taking the absolute value of the FFT of VAM. If you take the FFT of VAM, you will be getting the frequency information of amplitude modulated signal. Okay. So in this step, we are taking VF. So in order to plot the spectrum, we are defining this line. Okay. Then Next, we are going to plot the modulating signal or message signal and carrier signal. So in this program, how we are going to plot means we are taking two figures. We are taking two figures. In the first figure, here we are getting the output in two figures. Okay. In the first figure, in figure 1, that is in the first figure, we are plotting the modulating signal or message signal. Modulating signal. In the first figure, we are plotting the modulating signal and carrier signal. Okay. So in the first figure, we are plotting the modulating signal and the carrier signal. And in second figure, that is in figure 2, we are plotting the modulated signal. We are plotting the modulated signal and the spectrum. Okay, so here how you are getting the output means you are getting the output in two figures. In the first figure, you are getting the modulating signal and carrier signal. And in the figure 2, you are getting modulated signal and spectrum. Okay, so in figure 1, you are getting two plots. So we have to go for subplot. So here next step is we have to plot the modulating signal and carrier signal. And first we are taking figure 1. Okay, this command will generate figure 1. Now in figure 1, we want two plots. Okay, so you are using subplot of 2 1 1. The first one is number of rows, second one is number of column, and the third one is figure number. Okay, subplot of 2 1 1 means first one, it is having two row. Okay, one column, and the last one define the figure number. So first we are defining subplot 2 1 1. First we have taken figure 1. Okay, so it will generate figure 1, subplot 2 1 1. So in figure 1, you will be having two figures. The subplot of 2 1 1 is first figure. Plot of t comma vm. T is x-axis, vm is y-axis. So vm is nothing but the message signal. Okay, message signal or modulating signal. Okay, so plot t comma vm will plot the modulating signal. Next we are giving title is am modulating signal. Then in x label, in x-axis it will give time, y-axis amplitude, grid on will enable the grids. Okay, so first we have plotted the modulating signal in figure 1. Okay, now we are going to plot the carrier signal in figure 1. So used to subplot 2 1 2. 2 1 2 is, this is figure 1, this is 2 1 1, and this is 2 1 2. Second row, one column, second figure. Plot t comma vc. Vc is nothing but carrier signal. Okay, vc is carrier signal. So it will plot the carrier signal. In x-axis you are having time, and in y-axis you are having the carrier signal. Okay, the title is am carrier signal. So in x-axis you are giving time. So x label time. In y-axis amplitude. Okay, y label amplitude and grid on. Okay, so we have completed the first figure. The first figure is having two subplots. Okay, one is your modulating signal, another one is the carrier signal. Okay, now next we are going for figure 2, the second figure. This command will generate the next figure, figure 2. Figure 2, subplot 2 1 1. This is subplot 2 1 1. plot of t comma VAM. VAM is nothing but modulated signal. Modulated signal. Okay. Next we are using hold on. Hold on will keep the figure. Okay. Now plot t comma. Now already we have defined the upper envelope and lower envelope. What we have defined? We have defined the upper envelope and lower envelope. Now we are going to plot the upper envelope and lower envelope. In the same figure itself, you are drawing the you are plotting the upper envelope and lower envelope. Plot t comma v1 comma r. This r means your plot will be coming in red color. Okay, this is your x-axis, this is your y-axis. This t is x-axis, v1 is upper envelope, and your upper envelope will come in red color. R means this plot t comma v2. V2 is your lower envelope, and it will also come in the red color. Then you'll be giving the title as AM waveform in time domain, then X label time, Y label amplitude, then grid on. Okay. Now we are going for the next plot. So in this plot you are drawing the upper envelope. You are drawing the upper envelope as well as the modulated signal. Okay. First diagram. The second one, you are going to draw the spectrum. Okay. So this is subplot 2, 1, 1. This is subplot 2, 1, 2. Okay. So we have defined the subplot 2, 1, 2. Then, so for the spectrum, your x-axis is nothing but frequency. Okay. So x-axis is frequency. So we have multiplied the frequency by 10. Plot f into 10 is nothing but your x-axis frequency, and y-axis you are having your VF. Already we have taken the absolute value of your FFT. FFT will be giving the frequency information. Okay. So plot f into 10 comma VF. It will plot the spectrum. Okay. Now in the x-axis value you are providing. For the spectrum, the x-axis value you are providing. For that, we are using that command axis. You are using the command axis inside the bracket, and again inside the square bracket, FC minus 6 into FM, FC plus 6 into FM, 0 comma 10. This is the x-axis value of your what? X-axis value of your spectrum. Then you are giving the title AM waveform in frequency domain. So drawing in the frequency domain is nothing called spectrum. Okay. X label is frequency, Y label is amplitude, and grid on. Okay. So this is an explanation of your simulation of AM and its spectrum. Okay. Simulation of amplitude modulated signal and its spectrum. Students, this is the output of your program. Okay. So please listen. This is the AM signal. AM modulating. This is a message signal. Okay. This is your message signal. So here the amplitude is 1 volt. Okay. Now we have taken the. So this time period is nothing but 1 divided by FM. So you have to take the time period as 1 divided by FM. In that you have to draw one cycle. Okay. So 1 divided by FM is a time period. In that time period you have to draw one cycle of your FM. Then you have to continue the next cycle in the next time period. Okay. So here the amplitude, we have taken the amplitude Vm as 1 volt. Okay. So how much we have taken for your so FM is equal to 20. Okay. You have taken 20 volt. So 1 divided by 20 is your time period. That is 0.05. 1 divided by 20 is 0.05 is a time period. So within 0.05, you have to draw one cycle. You have to draw one cycle. Okay. This is your zero line. This is your modulating signal or message signal. Okay. Now we are going for the carrier signal. So for carrier signal, the amplitude is 1 volt. Amplitude is 1 volt, but the frequency is 500. So 1 divided by 500. Okay, 1 divided by 500. So that is your time period. So within 1 divided by 500, you have to draw one cycle. Similarly, you have to repeat. So this is your what? Carrier signal. Next, this is your amplitude modulated signal. Okay, modulated signal. Next one is modulated signal. So how you will draw the modulated signal means from the zero line to this is your VC 1 volt you have to take, and from this point you have to draw the modulating signal, message signal. From this point you have to draw the message signal. Okay, you have to draw the message signal. You know that the time period of your message signal is 0.05. So you have to complete one cycle within this 0.05. Then again you have to start. Similarly, you have to draw the negative side. From 1 volt, you have to draw this is your upper envelope, this is your lower envelope. Then you have to draw the carrier wave. Okay, carrier wave frequency is 1 divided by 500. Okay, and you have to change the amplitude. You have to only change the amplitude, but the frequency will be same. The carrier frequency, wave frequency will be same. Just you have to only change the amplitude depending upon the modulating signal. So you will be getting the what? You will be getting the AM modulated signal. Okay, next one is our spectrum. Next one is spectrum. So please listen. So the spectrum, you'll be getting three values. That is, you'll be getting three values. One is FC. This will be your spectrum. FC plus FM, FC minus FM. Your FC is 500 and your FM is 20. So you'll be getting FC plus FM is 520 and FC minus FM is 480. Okay. So you check whether you are getting, this is your 500, this is your 500 and this is 520, this is 480. So we are getting the spectrum. Okay, this is your output. This is the output of your program. Okay, this is output of your program. So we have written the program for AM and we have simulated its output and its spectrum. Okay. Now we are going for the FM modulation and its spectrum. Okay. Now the expression for the single tone FM is f of t is equal to Vc into cos of 2 pi Fc into t plus 2 pi kf into integration 0 to t m of t into dt. Now m of t, message signal m of t is equal to Vm cos 2 pi fm into t. So Vc into cos 2 pi fc into t plus 2 pi kf into, you are substituting the message signal, that is Vm into cos 2 pi fm into t into dt. Okay, now Vc into cos 2 pi fc into t plus 2 pi kf into, this Vm is constant, this Vm is constant, that we can take it outside. Then integration of 0 to t cos 2 pi Fm into t into dt. Okay, now Vc into cos 2 pi Fc into t plus 2 pi Kf Vm. Integration of cos 2 pi Fm into t into dt is nothing but sin 2 pi Fm into t. Okay, divided by 2 pi Fm. We have to put the limit 0 to t. Okay, now we'll be getting Vc cos 2 pi Fc into t plus 2 pi Kf into Vm. This 2 pi Fm we can take it here. When you're substituting the limit 2 pi Fm into t minus sin 0. Sin 0 is 0. So you'll be getting sin 2 pi Fm into t. Okay. So this 2 pi and this 2 pi will cancel. You'll be getting Vc into cos of 2 pi Fc into t plus Kf Vm divided by Fm into sin 2 pi Fm into t. This Kf Fm into Vm by Fm, we can take it as modulation index. So Vc is equal to cos 2 pi Fc into t plus modulation index m into sin 2 pi Fm into t. This is the expression of what? This is the expression of your Fm. Okay, this is the expression for your Fm. Now we are going into the program. So we are going for frequency modulation. So you know that for modulation we need two frequencies. One is carrier frequency and another one is message carrier signal and message signal. So first we are defining the frequency of message signal, that is 250 Hz. Then we are defining the frequency of carrier signal, that is 5 kHz. Then we are taking the amplitude of message signal as 1 volt and carrier signal as 1 volt. Okay, then we are taking the modulation index as 10. Okay, we are taking the modulation index as 10. Then we are defining the time axis from 0 to 0.0999 and the increment is 0.00001. Okay, now these are the things first we are defining. So carrier amplitude is 1, message amplitude is 1, message frequency is 250, carrier frequency is 5000 Hz. Okay, 5 kilohertz is 5000 Hz, and the modulation index is 10, and Kf value we are taking it as 100. Kf value we are taking it as 100. Okay, now we are defining. So here also we are drawing we are having two figures. In the first figure, in figure 1 we are drawing the message signal or modulating signal and carrier signal. Okay, in figure 2 we are plotting the modulated FM signal, and spectrum. Okay, we are drawing two things. First one is modulated FM signal, next one spectrum. Okay, so we are defining the x-axis for the first three. For the first three, the x-axis is a time axis. So we are defining the time axis. T is equal to 0 to 0.0999 and the increment value is 0.00001. Okay, then we are defining the frequency axis, that is 0 to 99990. Okay, then increment is 10 Hz. The increment is 10 Hz. Okay, now next we are going to define the carrier signal, Vc cos 2 pi Fc into t, and message signal Vm cos 2 pi Fm into T. We have defined the carrier signal and the message signal. Now we are defining the FM modulated signal. Now only I have explained what is the expression coming, that is Vm into cos 2 pi Fc into T plus modulation index into sin 2 pi Fm into T. So this is, we have defined the FM signal. Okay, we have defined the FM signal. We have defined the FM signal. Now, in order to find the spectrum, we are taking the FFT. What we are doing? We are taking the FFT. Okay, we are taking the FFT in order to find the next. In order to find the spectrum, we are finding the FFT. Okay, we are finding the FFT of FM. Okay, so you know that if you take the FFT of a signal, then it will give the frequency information. Okay, then after finding the VF, so we are finding VF in order to find the spectrum. Okay, now after finding the VF, we are going for figure 1. Okay, in the first figure, you are plotting, in figure 1, you are plotting the message signal. So you are actually, your figure 1 will be having two plots. So this is a subplot 2, 2, 1, and this is subplot 2, 1, 1 and 2, 1, 2. So first we are defining the first subplot, that is 2, 1, 1, and plot t comma message. Plot t comma message will plot the message signal. Okay, so in the x axis you are giving time, and in the y axis you are giving amplitude, and in the title you are giving FM modulating signal. Okay, you are making the grid. Grid means in the graph you will be having boxes. Okay, now we are coming for the second one, subplot 2, 1, 2. So in figure 1, this is in figure 1 itself, figure 1, this is subplot 2, 1, 2. Plot t comma carrier. Plot t comma carrier will plot the carrier. So here also in x-axis you are giving time, y-axis you are giving amplitude, and in the axis, in the x-axis values you are giving 0, 0.01, minus 1.5, 1.5. These values you are giving. Okay, these values you are giving in the x-axis. The use of axis is we can define the values. Okay, we can define the values of x-axis. Then you are giving the title FM carrier signal. Okay, you'll be giving the FM carrier signal. Then you are making grid. So this, in this graph also you are getting grid. Then you are going for the figure 2. In figure 2 you are plotting the modulated signal and the spectrum. So figure 2 will generate the next figure. Figure 2. So it is also having two plots. So this is 2, 1, 1. This is 2, 1, 2. Okay. So subplot 2, 1, 1. Plot t comma FM. So it will plot the FM signal here. Plot t comma FM. Then in that, hold on means in the same plot you are going to plot the another thing, that is plot t comma message comma r. This r means in red color it will plot the message also over. It will over this modulated signal. It will plot the, actually the modulated signal of your FM is, in some places it will be having more frequency, in some places you are having less frequency. That is frequency modulated signal. So by using hold on, you are drawing the second plot, that is plot t comma message. This r indicates it in red color, it will be plotting. So the message is also plotted over this diagram. Here also you are giving the axis value 0, 0.001, minus 1.5, 1.5. Okay, this is the values what you are giving in the x-axis. So in x-axis X-axis is time, Y-axis is amplitude, and the title is FM modulated signal. Okay, then you are making the grid. Now we are going for the next one. Subplot 2, 1, 2. Now we are plotting the free spectrum. So this is a second diagram of your figure 2. This is a second diagram of figure 2. Okay. So subplot 2, 1, 2, plot F comma VF. Okay, already this VF will be having the FFT information. Already we have defined the F is a frequency. Here also we are giving the axis value, that is 0, 10 to the power 4, 0, 4. Okay. Then you are defining the X label, Y label and title. Okay. So you will be getting the spectrum of your FM. So now this is the output. This is the output. The first figure you are having two outputs. No, this is a modulating signal. The modulating signal, it is having an amplitude of 1 volt. From the frequency you have to take the time period. You have to take the time period and you have to draw one cycle in that particular time period. Next one is, this is a carrier signal. This is a carrier signal. Okay, this is a carrier signal. Here also the amplitude is 1. So from the frequency, 1 divided by F will give the time period. With that time period you have to draw one cycle. After that you have to continue. Okay. Now this is a FM modulated signal. This is a FM modulated signal. Please listen, the blue line, no, at this part the frequency is more. Whenever you are having more amplitude, the frequency is more. When you are having less amplitude or in the, okay, the negative of cycle, this is positive of cycle. If you take 0, in the positive of cycles the frequency is more. In the negative of cycle the frequency is less. So the frequency of the carrier is varied in accordance to the message signal. This red signal is nothing but the message signal. Okay, the red signal is a message signal. So with this message signal, depending upon this message signal, the frequency is varied. In the positive of cycle it is having more frequency, and in the negative of cycle it is less frequency. Okay, and this is nothing but the spectrum. This is a spectrum of your FM signal. So this is the output of your program. Okay, so the first figure having two things, that is your modulating signal and carrier signal, and the second one you are having the FM modulated signal and its spectrum. Okay, these are the this is a explanation of your FM and its spectrum. Oh, so we have simulated. So we have studied the program for the simulation of FM and its spectrum. Students, we are going to see how to write the programs in the MATLAB and how to execute it. Okay, so first you switch on your PC. After switch on your PC, then you have to click the MATLAB icon. Okay, you have to click the MATLAB icon. When you click the MATLAB icon, the MATLAB will be open. Okay, so after clicking the MATLAB icon, the MATLAB will be opening like this. So after this MATLAB, what I am using is 2015 version. Okay, so MATLAB what I am having is 2015 version. In the lab you are having 2012 version. Okay, so in order to type the program, we need an editor window. So here now you are having the workspace and command window. What are the two windows you are having? Workspace and command window you are having. So if you are having any errors, your command window will show the error. Now first I am going to open a editor window. So an editor window is opened. Okay, now in this window I am going to type the program. The first program is the AM and its spectrum. So first I am giving CLC, clear command window. Then clear all, then close all. Okay. Similarly, you have to type all the lines. Okay. You have to type all the lines. So you have to type all the lines of the. So after typing the program, you want to save. Okay. So first you have to create one folder. Okay. So after typing this program, we are going to save. So you click save. So here save as will be coming. So now I am going to the new my computer. I am going to the my computer, and in my computer in the D drive I am going to open one folder in my name. I am going to open one folder in my name. So I am writing it as Satish PBR Wits. Okay, I am typing with my name, and actually it is in D drive, Satish PBR Wits. So there I am going to save the program. The program I am saving with the name program 1. So while saving the program, you should not use a name as amplitude modulation or something. You should not use. Similarly, while saving, the first letter should be an alphabet. Okay. So I have saved the program. Okay. Now I have saved. Now what I am going to do means I am going to run this program. So I am running this program. Here you are having run F5. If you press F5 also, it will run. So I am running this program, and it will ask like this. So you click change folder, and output will be coming. So for execution it will take some time. Okay, for execution it will take some time. Okay, you have to wait. Students, now we got the output. We are having two figures, figure 1 and figure 2. First we are enlarging figure 1. In the figure 1 you are having two signals, that is modulating signal and carrier signal. Okay, if you want to zoom this, you can use the zoom tool and you can zoom. Okay, if you want to zoom this picture, then you can use the zoom tool and you can zoom. Okay, so it is zooming. Okay, so if you want to less the zoom, okay, if you want to zoom, you can use this. You will zoom and you can visualize. So next we are going for picture 2. In the picture 2 we are maximizing this. In the picture 2 you are having the amplitude modulated wave and the spectrum. Okay, amplitude modulated wave and the spectrum. So this red line, they are upper envelope and lower envelope. The red line is the upper envelope. The top you are having this upper envelope, the bottom you are having the lower envelope. And this is FC, this is FC minus FM, this is FC plus FM. Okay, so this is a spectrum of your AM. This is a spectrum of your AM. Actually here you are having your carrier frequency is 500 and your message frequency is 20. So you are getting 520 for FC plus FM and you are getting 480 for FC minus FM. So these are the outputs. Okay, these are the two outputs. This is output 1, figure 1, and this is figure 2. So we got the outputs. Okay, so we got the outputs for figure 1 and figure 2. Friends, next we are going to execute the FM and its spectrum. So first you have to click this after making your PC on. You have to click this MATLAB icon. So MATLAB will be opened. Okay, MATLAB will be opened. So after that we have to open a editor window.
So we have opened the editor window. In that editor window, we are going to type the program. Okay, first CLC, then clear all, then close all. Then we will be typing the entire program. Okay, we will be typing the entire program. So after typing this program, we have to save our program. So we'll be clicking save, save as. Then already I have created one folder, Sadish PBRVs. In that folder, I am saving this program. That is program. I am giving the name as program 2. And I am saving. I have saved the program. After that, I am running. Okay. So I am running this program. So it will take some time. Okay. Now we got the output. So we are having two figures. In the first figure, we are having the modulating signal and the carrier signal. Okay, this modulating signal and the carrier signal we are having. Okay, so if you want to zoom, you can zoom this picture. Okay, so now we are going to analyze the second figure. This is a second figure. Okay, this is a second figure. So here this is a frequency modulated signal. The red line, it is a modulating signal. The red line is a modulating signal and the blue line is a modulated signal. Okay, modulated signal. You check in the positive half cycle, the frequency is high, and in the negative half cycle, the frequency is low. So the frequency of the carrier is varied according to this modulating signal. Okay, so this is a positive half. In the positive half, the frequency is high. This is a negative half. In the negative half, the frequency is low. So this is frequency modulation. This is a frequency spectrum. Okay, so this is a spectrum, FM spectrum. Okay, so we got the output. So we have written the program. So we have typed the program in the editor window. We have saved and we have executed and we have got the output. Okay, this is the output. Okay, so you have to draw this in graph sheets, or you have to take the printout and you have to paste. Okay,